Today's discussion topic revolves around the subject of energy and pressure, which is the continuation from the previous slides. In the first set of slides, we discuss about what work is, kinetic energy, the law of conservation of energy, and different forms of energy. So, fasten your intellectual seatbelt for part 2, which is promises to be the cultivating continuation of our journey into the intriguing world of energy and pressure. Without further ado, let's get into it. Energy resource can be divided into two parts, which is renewable energy and non-renewable energy. Renewable energy talks about source of energy that can be naturally replenished or regenerated within a relatively short period. Renewable energy is considered as sustainable and environmental friendly, and these resources do not deplete over time and have a lower environmental impact. Example under renewable energy is solar energy, which is from the sun. Wind energy is from the wind. Hydroelectric energy is from flowing water. On the other hand, we have non-renewable energy. These sources of energy that are finite and cannot be easily replaced in a human time scale. Non-renewable resources are very limited, and their attraction and use can have significant environmental consequences. Example, fossil fuel like coal, oil, gas, and natural gas. And on top of that, another example will be nuclear energy. Let's look one by one at the non-renewable energy resource. Fossil fuel exists in the form of hydrocarbon that are derived from the meat of ancient plants and marine organisms. These organic material, which include dead plants, microorganisms, were buried under layers of sediment in the earth over millions of years. And the heat and pressure from the earth's geological process will transform these organic materials into fossil fuel, including coal, oil, petroleum, and natural gas. The advantages of fossil fuel is have high energy density, meaning that they provide a lot of energy for their volume and weight. Fossil fuel power plants can provide a stable and continuous source of energy, which is important for baseload electricity generation. A significant amount of infrastructure and technology is already in place to extract, process, distribute fossil fuel. The side effect of fossil fuel is the burning of fossil fuel releases greenhouse gases like carbon dioxide and methane into the atmosphere, which is contribute to environment climate change. They also release air pollutant that can harm environment and human health. Fossil fuel are finite resources and will eventually run out. As they are depleted, they become more difficult and expensive to extract. Fossil fuel price can be higher, volatile. If you can see from fossil fuel to the electrical energy, we can see is that the process of energy conversion involves chemical energy, heat energy, kinetic energy, and finally we have electrical energy. The second example of non-renewable energy resource is there are two types nuclear energy, which consists of two types, is either fission or fusion reaction. And this energy can be used for various applications, primarily in electrical generation. The advantage of having nuclear energy is a small amount of nuclear density fuel can generate a significant amount of electricity. But the setback of nuclear energy, one of the most significant challenges and severe risk of nuclear energy is the generation of radioactive waste. Building and maintaining nuclear power plants is also costly. And the past nuclear incident like Hiroshima highlight the danger associated with nuclear power plant. Renewable energy resource. First example will be solar power is an electricity or heat generated by using sunlight. And it is like turning sunlight into energy. And this is done using special panel or devices that capture the sun's energy and convert it into power that can use for lighting, heating, and running appliances. The advantage of having solar power at home or at the industries are limited renewable as long as the sun exists, do not emit gases or air pollutant. But the setback of solar power is the upfront cost of purchasing and installing solar panels can be extremely expensive. Large-scale solar installation requires significant space, which may not be practical in densely populated areas. Energy storage systems like battery are needed, adding to the overall cost, and the manufacturing and disposal of solar panel can have environmental impact, and recycling efforts are still evolving. And it is not an easy method which is available, especially at night and rainy days. And solar power, as you know, not everyone can afford to install solar panel. Second example of renewable energy resource is wind power. Wind power is a form of renewable energy that harnesses the kinetic energy of the wind to generate electricity. It is primarily generated using one turbine, which are tall tower-like structures with a large blade. The advantage of having wind power is being clean, sustainable energy source, reduce greenhouse gas emissions, and providing electricity in region with a strong and consistent wind. On the other hand, the disadvantage of wind power is efficiency depends on wind condition. Wind farm may face challenges, especially visual impact and noise. And turbine construction can be very, very expensive. The third example will be hydroelectric energy, which is under renewable energy resource. Hydroelectric energy is also known as hydropower and is a form of renewable energy that harnesses the energy of flowing or falling water to generate electricity. Hydroelectric power is generated through the following process, whether through water source, a river reservoir, dam area is used to collect water, turbine. Advantage, it is low greenhouse gas emission. On the setback or disadvantage of hydroelectric energy, the construction of large dam and reservoir can have environmental and social impact. Feasibility of new hydroelectric project often depends on the availability of water resources and ecological consideration. Dam, especially as a large dam or dams, are extremely expensive to build. Next, fourth example of renewable energy resource is geothermal energy. Geothermal energy is the heat stored beneath the Earth's surface to generate electricity and provide heating and cooling for various applications. The advantage of geothermal energy, it is a sustainable and environmental friendly energy option. It produces low greenhouse gas emission compared to fossil fuel, and it is most effective in regions with the most significant geothermal resources, such as volcanic area. On this disadvantage of geothermal energy is location dependent. It's most viable in regions with significant geothermal resources, such as area near tectonic plate boundaries or active volcanic zone. And the development and drilling of geothermal well can be very expensive, particularly power plant. Let's look into energy efficiency. Energy efficiency refers to the ratio of useful energy output to the total energy input in a system or process. And it measures how effectively energy is converted into useful work or services. And it is critical factors in minimizing energy waste and reduce cost. The formula to calculate the energy efficiency is useful energy output divided by total energy input multiplied by 100%. So energy efficiency in the form of percentage. Example, A car engine consumes 1000 joule of fuel energy to produce 300 joule of kinetic energy per vehicle. Calculate the energy efficiency of the car engine. Solution to this question is, from the question itself, we have useful energy output is about 300 joule and total energy input is about 1000 joule. To get the energy efficiency, you have to using the useful energy output divided by total energy input multiplied by 100, you get the value of 30%. So the energy efficiency of the car engine is 30%, meaning that 30% of the energy from the fuel is converted into useful kinetic energy for the car, while remaining 70% is lost as waste energy, typically in the form of heat and other inefficiencies. Let's look into power. What is power? Power is a measure of how quickly energy is transferred or converted. It's quantifying the rate at which work is done, the rate at which energy is consumed or produced. The SI of unit of power is the watt, 1 joule per second. Power is expressed as power equals to energy divided by time, where power is measured in watts, energy is measured in joules, and times is measured in seconds. Question. A machine does 5,000 of work in 10 seconds. Calculate the power output of the machine. Solution to this question is, given work in the questions is equal to 5,000 joules, times is 10 seconds. So to calculate the power, use the formula given, which is power equal to energy divided by time. Then you get the power is equivalent to 500 joules per second, which is in the form of watts. So the power output of the machine is 500 watt or 500 joules per second. So this means that the machine is doing work at the rate of 500 joules per second. Let's look into the new topic, pressure. What is pressure? Pressure is a measure of force applied over a specific area. It quantifies how force is distributed over a given surface area. The SI of unit for pressure is Pascal. The formula to calculate the pressure is pressure equal to force divided by the area, where pressure is measured in Pascal, PA, force is measured in Newton, and the area is measured in square meter. Let's look into Pascal's law. Pascal law is a fundamental principle in fluid mechanics that describes how changes in pressure applied to a fluid are transmitted undiminished in all directions throughout the fluid. Pascal law can be summarized as follows. When an external pressure is applied to an enclosed fluid, a gas or a liquid, the pressure change is transmitted throughout the entire fluid without loss, and it acts with equal magnitude in all directions. This principle explains how hydraulic system works. For example, if you apply a force to a piston in a hydraulic system, the increase in pressure is transmitted to the fluid, causing the piston on the other side to move. This enables the amplification of force in hydraulic system, making them valuable in a wide range of applications from a car brakes to heavy machine. Its principle can be used in various contexts, particularly in hydraulic system, where F1 divided by A1 equals to F2 divided by A2. F1 is a force applied to the first piston in a smaller cylinder. A1 is the cross-sectional area of the first piston. F2 is the resulting force exerted on the second piston in the large cylinder. Meanwhile, A2 is the cross-sectional area of the second piston. Pressure and depth. In a liquid of gas and pressure increases with depth, meaning that the deeper you go beneath the surface of the fluid, the greater the pressure you will experience. Pressure and depth in fluid can be expressed as P equals to rho multiplied by G multiplied by H. P is the pressure at a certain depth in Pascal. Rho is the density of the fluid in kilogram per cubic meter. G is the acceleration due to gravity in meter per second squared. and H is the depth below the surface, which is in meter. Barometer and manometer. Barometer is a specific instrument used to measure atmospheric pressure. It helps to determine the weight of the air above the specific location on the Earth's surface. Atmospheric pressure is the force exerted by the weight of the air molecules in the Earth's atmosphere. These are the examples collected which shows that barometer. This manometer is a device used to measure the pressure of gases and liquids. It provides a way to determine the difference in pressure between a reference point of an atmospheric pressure and the pressure of the substance being measured. So these are examples of pressure gauge. So you can see how this pressure gauge is installed. With that being said, that's all for today. Thank you for listening and hope that you are doing well in your studies. By the way, please don't forget to subscribe to Jom Study Lab YouTube channel. And thank you very much for your concern and listening. Hope to see you in the next presentation slide.